formulating and solving solutions to systems of equations of linear and quadratic functions. So let's look at this first problem that says an asteroid is traveling toward Earth on a path that can be modeled by the equation y equals 1 over 28x minus 7. And this is the first equation that's given. I see that there's no squared value, so I know this is going to be linear. It approaches a satellite in orbit on a path that can be modeled by the equation x squared over 49 plus y squared over 51 equals 1. This equation has squared portions in it, so I know that this will be my quadratic equation. Even though if we were to graph this, it would be an ellipse. And so you could graph this equation and describe the radii from the graph and the equation. So answer that in your journals, but then we can finish the problem by reading the question stem, which says, what are the approximate coordinates? So points of the points where the satellite and the asteroid might collide. So we're looking at this elliptical orbit, and if the satellite coming in at a linear direction will intersect with it and how many times. So let's look at the linear portion because our steps say to substitute that y in there to the quadratic equation, and we see that that y will be squared. So let's square the y, and we can square it to the side. And y squared is all of what y equals squared, y over 1 over 28x minus 7. So y squared will be equal to 1 squared over 28 squared times x squared minus 2 times 7 over 28x plus 49. And another question you can answer is, why do we know that? I was going to say I, but we do. So let me rewrite that. Why do we know that, or how do we know that? And then we can substitute that in for y squared. So we have 1 over 49x squared plus 1 over 51 times 1 over 28 squared x squared minus 1 half x plus 49. And another question you can ask yourself, answer in your journals is, well, what are the other steps to simplify? So what are the in between steps to simplify? From our side work over here. So, and then all of this would be equal to 1. And then we would distribute and collect like terms. So we've got 1 over 49x squared plus 1 over 51 times 1 over 28 squared x squared minus 1 over 51 times 1 half x plus 1 over 51. times 49 equals 1. So notice the 1 over 51 is listed 3 times because there are 3 things inside the parentheses. And then we would multiply across to simplify even further. 1 over 49x squared plus 1 over, and 51 times 28 squared is, let's see, times 51 is 399.84. 399.84 x squared minus 1, so this is times 1 half, 51 times 2, let's do 51 times 2, 51 times 2, 102, so 102x plus 49 over 51 equals 1. This would be minus 1, and think about, right, y subtract 1. Why would I subtract 1? Which would really be 51 over 51. So then we would simplify this further to be 1 over 49x squared plus 1 over 399.84x squared minus 102x, let me write that neater, 102x minus 2 over 51, 2 over 51 equals 0, and then I would combine my like terms. What are my like terms? They would be our variables with the same coefficients. So now 399 and 399, 84, and 49 obviously aren't the same, but I could multiply that 1 over 49 by something that could get me 399.84. Let's see what that would be. 99.84 divided by 49 is 816. So times 816 times 816. And why does that work? Right? Why does that work? Answer that in your journals. And we would get 816 over 399.84x squared plus 1 over 99.84x squared minus 102x minus 2 over 51 equals 0. And we're almost done because now we can combine these pieces and get our equation into standard form. Ax squared plus bx plus c equals 0. So we would have, because after all of this, you just need to be concentrated on that standard form. So we have 817 over 399.84x squared plus or minus 1 over 102x minus 2 over 51 equals 0. And once you have it in standard form, we can get rid of these awful fractions. Right, that now is when I would get rid of those awful fractions. So let's look at these awful fractions and just concentrate on the equation we've gotten into standard form. And let's take 817 over 399.84, and that is, let's use our star pen because we're talking about stars. And we'll get our equation that we will solve with the quadratic formula negative b plus or minus the square root squared minus 4ac over 2a. And these would be our x values. So let's find an a, b, and c we can work with. 0.0204x squared, and then negative 1 over 102, 1 divided by 102, and that is minus 0.00980x, and then negative 2 over 51, and then we have 2 divided by 51, and that is minus 0.0392, and all of this would equal 0. And now we've got an a, b, and c we can work with in the quadratic formula. A equals 0.0204, b equals negative 0.00980, and c equals negative 0.0392. And that is how I would solve it, by putting it into the quadratic formula, plus or minus b squared minus 4ac over 2a. And if we've got a negative b, it would turn positive. So x equals 0.00980 plus and minus the square root of negative 0.00980 squared minus 4 times 0.0204 times negative 0.0392 all over 2 times 0.0204. And you should get two values for x, which means you should get two values for y, because you should get two coordinates, x1, y1, and x2, y2, which means there would be 2 points on the elliptical orbit that the asteroid would intersect the satellite. And I'll leave you to solve the rest of that quadratic formula and the rest of these practice problems. The nice part about these practice problems is most of them give you the equations. Some of them you might have to formulate yourselves, but it's good to note that these are separate problems.